Good morning and welcome. Thank you for joining us for the third installment of our John Marshall Everglades Symposium. Thank you to all of those joining us live today in person as well as virtually, and happy World Water Day. I can't think of a better way to spend our morning than learning about the science behind our water. Now, before we get started, I would like to thank Glenmede, the sponsor of this year's event, and our facility for hosting us today. My name is Tate Vangellow. I am the Everglades Literacy Program Coordinator for Southwest Florida at the Everglades Foundation. But without further ado, I'm going to introduce today's panel. Today, we are joined by Dr. Steve Davis, who is the Everglades Foundation Chief Science Officer. He is a native of Ohio who earned his PhD from Florida International University in 1999 with research in Florida Bay and coastal Everglades. Dr. Davis joined the Everglades Foundation in 2009 as a member of the science department, and he became a key voice in support of the organization's mission to restore America's Everglades. He draws upon his 25 years of Everglades science and teaching experience, including 10 years as a professor of wetland ecology at Texas A&M University, to lead science, communication, and outreach efforts focused on the Everglades restoration, ecosystem health, and impacts of sea level rise. Thank you, Dr. Davis, for joining us today. We are also joined virtually today by Dr. Cindy Heil, who is the director of the Red Tide Institute at Mote Marine Laboratory in Sarasota, Florida, which focuses on studying and testing Florida red tide mitigation and control technologies to improve the quality of life for coastal communities affected by these challenging, harmful algal blooms. Heil earned a doctorate in oceanography at University of Rhode Island. She studied development and implementation of marine plants during a fellowship at University of Queensland Marine Botany Group. She was also a research scientist at USF, Florida Fish and Wildlife, and Bigelow Laboratory for Ocean Scientists before joining Mote Marine Laboratory. Thank you, Dr. Heil, for joining us today. Last but certainly not least, we are joined in person today by Dr. Michael Parsons, who is a professor of marine science at Florida Gulf Coast University and is the director of the Coastal Watershed Institute Investor Field Station. He was a State of Louisiana Board of Regents Fellow and received his doctorate from Louisiana State University in 1996 in biological oceanography. In 2019, he was appointed to serve on the Blue-Green Algae Task Force, which is charged with focusing on expediting the progress toward reducing the adverse impacts of blue-green algae blooms now and over the next 5 years. Thank you for joining us today, Dr. Parsons. The chat is open, so if you have any questions, we're more than happy for you to drop those in the chat. This structure of today's talk will be some prepared questions for our panelists, and then we will follow with a public Q&A from our live audience as well as our virtual audience. But without any further ado, I'd like to begin with our first question, which is for Dr. Davis. Today we are here in Naples. Can you tell us how the Everglades is important to this area?
Well, where to begin? You can't really be in South Florida and not be affected by the Everglades to some degree, especially in this current modified, drained, replumbed state where we have water that used to flow historically from Lake Okeechobee to the south, all the way to Florida Bay and the Florida Keys, where now that water flow has been interrupted and it's discharged to the east and west coast. In unnatural volumes, high volumes of freshwater flow that wreak havoc on the estuaries on both coasts, upsetting the balance of salinity that's really obviously important for oyster habitat, seagrasses. And so that volume alone is harmful to both coasts. When you add in the fact that over the decades, Lake Okeechobee had become polluted, that 100+ mile meandering river from Lake Kissimmee down to Lake Okeechobee was straightened into the C-38 canal. That allowed for agriculture to expand in that watershed. Over time, that watershed from the north, as well as back pumping of polluted runoff from sugar fields, has led to a legacy of pollution in Lake Okeechobee. We still see high pollution levels, primarily phosphorus, coming into the lake today from the north, but there's a legacy of pollution within the lake that we know is fueling blooms of algae. When those releases are made to both coasts, it's a double whammy because you've got the freshwater discharges in those unnaturally high volumes, as well as the load of pollution and oftentimes blue-green algae that comes along with it. That affects our coastal waters. That affects the health of fisheries. It certainly impacts our tourism and risks human health as well. So it's really a negative story today, but with Everglades restoration and what we advocate for at the Everglades Foundation, it's fixing our water, which is not only replumbing the system so that we can send that water south, reduce those polluted discharges, but also so that we can clean the water before it goes back to the Everglades. So that's the win-win scenario that Everglades restoration provides and benefits all of South Florida.
Great. Thank you, Steve, for sharing that. And I think always bringing back the locality to, how the Everglades connects to each location is so important. So thank you for sharing that. You had mentioned blue-green algae. So this next question is for Mike. Can you speak to what blue-green algae is specifically and how it affects our communities here in Southwest Florida?
So blue-green algae is the common name for cyanobacteria. And so cyanobacteria are a kind of bacteria, as you can tell by the name. They photosynthesize like algae and like plants, and they have different pigments that give them this blue-green color. So that's why we call them blue-green algae. But they're bacteria. They're actually not algae. So there's cyanobacteria everywhere. Some of the oldest fossils on the planet are cyanobacteria, billions of years old. So they've been here for a very, very, very long time, and they've adapted to all kinds of environments. There are marine forms that live in the Gulf of Mexico and elsewhere in the ocean. There are freshwater forms that live in Lake Okeechobee and in the brackish waters in between. So that they are everywhere, and they're an important part of our ecosystem. But they become a problem for us and for ecosystems when they bloom. And so they've been blooming for a long time. I remember as a kid going to visit my grandparents in Iowa, and there was Spirit Lake that was just green. And we didn't even know about the toxins back then, and we went swimming in it. That might explain some of my behavior these days. But anyway, we know it's a problem, and we know that these blooms can present a human, animal, and ecosystem health risk. And if you jump and fast forward, let's say to 2016, where we had a big microcystis bloom on Lake Okeechobee. Microcystis is one of these cyanobacteria freshwater forms that is a bloomer, so it can become a nuisance and make these huge biomasses. That became a problem over in the St. Lucie River, Stewart, elsewhere on the East Coast. And then go to 2018, 2019, we had a similar problem on this coast. So microcystis is basically the one that's really causing issues here. It's always around. We can go collect a water sample over here right now, and you'll find microcystis. It just won't be blooming. And there's a lot of other cyanobacteria. So the big issues, as Steve was mentioning, would be why are these cyanobacteria blooming in our freshwater systems now? How does that relate to the nutrient inputs? How does it relate to the fact that we replumb the system? How does it relate to the fact that we have these chronic issues that restoration is trying to fix? And so that's a lot of what we're trying to work on that cyanobacteria blue-green algal front.
Great. Thank you so much for that answer. And I think it's very thorough. I should have you come teach my students. I work for the education department. So that was a great answer to explain blue-green algae. And I share actually a similar childhood experience that in the lakes. So maybe that explains myself as well. But similarly, this next question is for you, Dr. Heil. Can you explain specifically what red tide is and how that affects our Southwest Florida communities?
Well, good morning, everybody. And I apologize for having to be remote, but thank you very much for the opportunity to participate here. Red tide is essentially the common term for a harmful algal bloom of the dinoflagellate Karenia brevis. If you live in Southwest Florida, you know what red tide is. It's downstream from the Everglades, potentially impacted from the management practices of the Everglades system itself. What a red tide is, it's a bloom or an aggregation of a species called Karenia brevis. It's a dinoflagellate, very evolutionarily old. It is endemic. It lives here in the Gulf of Mexico, particularly the eastern Gulf of Mexico. It is a single cell dinoflagellate, and it's incredibly complex for a single cell. It's motile. It swims. It has flagella. It swims toward the light, away from gravity. Has a very complex nutritional mode. Your lawn uses inorganic nutrients. Well, a dinoflagellate like Karenia brevis uses inorganic, nitrate and ammonia, but also complex organic. It has the enzymes to use organic nitrogen and phosphorus. lately we've been documenting the fact that it also ingests other algae. So it's very complex, but it's photosynthetic, like your lawn. We know and I forget to mention, probably the most important fact about Perennia brevis is it's toxic. It is always toxic. There's a suite of 13, I believe now, different brevitoxins within the cell, and that's what all the impacts are. If it wasn't toxic, we'd be a lot less worried about this particular species. We know a lot about its life cycle, the life cycle of a bloom. We know these blooms start offshore on the shelf. They develop, move inch, grow. It's not a very good competitor. It needs to be by itself for a while to grow. When it hits the shore, we get very large, very destructive blooms often. They vary in intensity and duration and impacts each year. But what people focus on is the effects. There are significant human health effects. They do accumulate in shellfish, making the shellfish toxic. In terms of management, the state actually does a fairly good job of managing the shellfish. There's only half a dozen cases each year of people getting sick from consuming toxic shellfish related to red tide. But what most people are concerned with is aerosol production. And when cells get into the beaches, the toxins actually from the cells get into the water and are injected into the aerosol. So at the beach, you breathe in the toxins from red tide. And that affects the most people, both native as well as tourists within the state. There are significant environmental impacts that vary from year to year, everything from marine mammal mortalities to fish kills. This past year, our bloom was so severe that over the 2 months of June and July in Pinellas County in Tampa Bay, they removed over 1,800 tons of dead fish from the beaches at a cost of about $7.5 million. So the economic impacts can also be as severe as well as the environmental impacts. And since the 18 Bloom Act, there's actually been quite a lot of research on the on the economic impacts. So we're starting to get a handle. Estimates can be up to literally $1 billion from a bad red tide in 2018. And people are starting to realize it's not just direct impacts of tourists not going to the beach, there are indirect impacts. The loss in value of property near the coast is a good example of that. So red tide is a native feature of the shelf or the Southwest Florida. We know from the history that we've had them going back at least to 47 when the organism was described, but from other descriptions, probably dating back to the first Spanish explorers. We know quite a lot about red tide, but we're essentially in the infancy of managing these phenomena in Southwest Florida.
Great. Thank you for that answer, Dr. Heil. Again, a great explanation in understanding this complex problem in our ecosystem. I think that you explain it very well and thoroughly. Thank you for that. I know red tide, I live in Sarasota, is a big problem for us. Previous to my time with Everglades Foundation, I actually was an intern with Florida Fish and Wildlife and participated in about 25 different rescues of manatees across the entire state of Florida in a 4-month period. So it's definitely an impact that's felt far and wide across our state. So thank you for that. This next question is for Steve. You've experienced all these algae events and blooms across the ecosystem. So can you speak to a specific event and how Everglades restoration could help prevent this?
Well, I'm going to go a little bit outside of where we're talking about today and the Florida Gulf Coast and the shelf. The red tide events are fairly well documented, and Dr. Heil's work has shown a connection between discharges and the potential to fuel those events. We know that the blue-green algae originates in Lake Okeechobee, and those discharges are in such high volume that they render our estuaries as lakes, basically polluted extensions of Lake Okeechobee to where this freshwater cyanobacteria can flourish. But I want to talk a little bit about Florida Bay, and it is connected to the health of this ecosystem. In fact, that fresh water that's being dumped to tide historically would have made its way south into Everglades National Park and ultimately to Florida Bay. The issue there, though, isn't water quality. It's actually water quantity. It's a lack of fresh water making its way into Florida Bay that during extremely dry years, we see a change in the health of Florida Bay to the point where salinity levels exceed that of the ocean and can be upwards of 2 times the salinity of the ocean. And we get seagrass die-off, and that leads to algae blooms. And it's another species of cyanobacteria that flourishes in salty water. But we see blooms of algae occurring down there simply because we're not getting enough fresh water flowing south. So I think it's important to just point out that while these are clearly water quality issues in Lake Okeechobee, the Caloosahatchee, the St. Lucie, and the discharge impacts that has on our nearshore waters, because we're not sending that volume of fresh water to the south, we're also getting algae blooms down there in the Florida Keys and around Florida Bay as well, to the point where when we have a seagrass die-off event like we did in 2015, we see an annual inflammation of these blue-green algae blooms in Florida Bay. Here we are 7 years after that die-off event, and we're still seeing some of the basins in Florida Bay showing very high concentrations of cyanobacteria, and that will persist based on our experience for another 4 to 5 years as that bay and seagrass continue to recover. So all that to say, we've got pollution problems here. We know restoration will fix because we're sending that water south. We'll pass that water through a massive network of stormwater treatment areas that the state of Florida has built to clean up that agricultural pollution. Sending more of that water south will also prevent algae blooms in Florida Bay.
Great. Thank you, Steve. Thank you for providing that vivid imagery of this problem being an inflammation, and so well explaining it, how restoration can help prevent some of these events. This next question is for Mike. Through your research, you've understood more about some of the harmful health impacts we see from blue-green algae. And can you dive into those findings a little bit more?
So with the blue-green algae, most of the previous research focused on water exposure. So if people are swimming in the water, if they're accidentally drinking the water, or if the toxins could work their way through a drinking water treatment system. That happened in Toledo, Ohio, for example, back in 2014. So that was where a lot of the focus was on, and with animals. So back in 2016 and more so in 2018, there were dogs that were killed by basically running up to the edge of a canal or an edge of a pond where there was a big cyanobacteria bloom, and maybe eating a dead fish, maybe just eating that algal biomass or drinking the water, and they got a fatal dose of the toxins. In this case, it was with microcystis that I mentioned before, and the group of toxins they produce are called microcystins, and they're a hepatotoxin, which means they cause liver damage and kidney damage, and they can cause a lot of internal bleeding and things like that. So more recently, the on aerosol and get airborne, and people can breathe the toxins in. And so a lot of our Lori Baker at Center for Disease Control, CDC, she pioneered a lot of this work. She also was heavily involved in the aerosolization of the brevetoxins 10, 15 years ago. And we've been continuing work. I'm working with Lori, trying to get a handle on how much toxin is in the air, and is it actually a risk or not? So we can measure the toxin. We had air samplers out in Cape Coral last week. We're sampling right now over in Stewart. We can measure if it's a dangerous amount of toxins. So part of the other part of the projects that we're working with people over at Harbor Branch and Florida Atlantic University is the human side of it. So we're doing nasals, we're collecting urine and blood samples to see if we can measure the symptoms developing in the people. And there has been other work done, for example, that looks at non-alcoholic liver disease. And there is some evidence, well, there's relationships, I shouldn't say it's evidence, where if you have an increased frequency of cyanobacteria blooms, there also is an increased frequency of non-alcoholic liver disease. And again, microcystins are a hepatotoxin, they affect the liver. So there might be some connections there. So it's really in its infancy right now. And we had air samplers set up at a gentleman's house in Cape Coral. And he said, am I going to die if I walk out in my backyard? And I answered, I'm like, probably not, but something else a tree might fall on you. I don't know, but we don't know enough. I just said, I don't know. If you're uneasy, if you don't feel well, go somewhere else and get some fresh air. We just don't know. And that's a hard answer to give, but it's the honest answer.
Great. Thank you so much for explaining the research that has happened, as well as the research we can look forward to understanding these health impacts a little bit more. So thank you for that. This next question is for Dr. Heil. In the past few years, we've seen these red tide events coming closer and closer to shore and lasting for longer and longer periods of time. So can you speak to your research and understanding what the contributing factors to these intensifying events are?
Okay. Yeah, that's a very good question on a lot of people's minds right now. We've had two very, very severe red tides recently in 2018 and 2021. They were separated by what we consider a normal red tide. And what a lot of people don't realize is we generally see a red tide every year. It's more common than to not see a red tide, which I can count on the fingers in the last 70 years. But these are very unusual red tides for a number of reasons. We've got a fairly good idea what's contributing to them, and I can talk about. But I've got to explain what I call a normal red tide. If you look at the historical record, and we are probably one of the best global records for red tide here in Florida, going back at least to the early 50s, we know what a normal bloom is. We know these blooms start anywhere from late August through probably November. On average, they last 5 to 7 months, although they can last up to 36 months. And they generally end in April. There seems to be this termination date that we've identified. That's a normal year. And we had one of those in actually 2019, a 4-month bloom. That being said, 18 and 21 were very anomalous years. We had blooms over winter, which is very unusual. They blasted through that April gate into the summer. And one of the things we're looking at is what causes these blooms to be atypical? Why do they last so long? Why do they extend into the summer? What are the nutrients contributing to them that let them do that near shore? What are the weather patterns? One of the things we've identified is the timing of the switch from the dry season to the wet season. If you live in Florida, we have a wet season in the summer. It rains every day for about 4 months. And then we have a dry season where it barely rains. And the timing of the shift from the dry to the wet season seems to be contributing to these summer blooms. And we've had 2 in the last 4 years. That's a little ominous. If you go back to 1947 overall, we've had 9 of these summer blooms. So having 2 recently is extremely alarming. The 018 bloom we know quite a bit about. In localized areas, we know there was a lot of rainfall in Southwest Florida. There were a lot of releases out of Lake Okeechobee. Those releases included the cyanobacteria, which traveled with the coastal waters. And a cork of microcystis, although it won't grow in salt water, it can persist for several days. Sorry for the background noise. Before it degrades. And work I did with us and the Everglades Foundation, we found localized area that's sufficient to support that bloom. Of course, the bloom stretched to the panhandle, so there are many other nutrient sources. We've identified over 13 that came into play with a particular bloom. 18 was unique because we had the overwintering bloom and we had a brand new bloom start that year that kind of butted up against it and combined to make like a super bloom. Essentially, very, very different. We had a late start, an overwintering bloom. It was very dry, drought conditions, and some very unusual wind patterns. The winds were from the south for an extended period. And if you know anything about winds on water, the direction of the wind moves the water to a 90-degree right angle. So the wind's blowing from the south. We also had some unusual nutrient events. In the Tampa Bay region, we had the Piney Point effluent disaster. Literally within the space of 2 weeks, we had the annual equivalent of the nitrogen inputs to Tampa Bay, southern Tampa Bay, because the winds were from the south that kept it within the bay the whole period. The bloom was not close then. It took 2 months to come to Tampa Bay. The immediate effect was a diatom bloom, but all those nutrients were cycling in the system. So they probably contributed to the severity of the bloom this particular year in Tampa Bay. And the interesting thing is once that bloom entered the bay, we'd had the drought previously before the rain started, so salinities were elevated. Nothing kept it out of the bay. And when it started killing fish, it was almost a self-perpetuating bloom. Fish kills are actually the #1 nutrient source in terms of amount of nutrients for red tide. So this was kind of a rather horrific self-perpetuating disaster through the summer in Tampa Bay. So we've learned quite a bit about these anomalous blooms. We don't know enough to say if they're a trend now. But what I usually tell people is so many people immigrating to Florida each year, and that's continued in the pandemic. There are more and more people getting exposed to red tide and the impacts of red tide. So yes, there potentially is a trend toward increase. We don't know that, but we do know that more and more people are getting impacted by the effects of red tide.
Great. Thank you, Dr. Heil, for that answer and for explaining the difference between normal red tide and anomaly red tide, because I think that's a common misconception for Floridians. But even just going back to your point and understanding that so many people are moving to Florida, I mean, we're seeing between 1,000 to 2,000 people moving to Florida every single day. And of course, that's going to put a stress on our water that we haven't seen before. And of course, more exposure to red tide. So thank you for shedding the light on that. This next question is for Steve. Steve, in the recent years, the U.S. Army Corps of Engineers has been reviewing Lake Okeechobee System Operating Manual, or LOSOM. How would changes in the regulation of the lake affect water quality in Southwest Florida?
Well, as many people have probably seen in the news, especially over the past 6 months to a year, a lot of attention focused on the Army Corps of Engineers LOSOM planning process. This is the Lake Okeechobee System Operating Manual. It literally is a rule book for how the Corps will manage water flows out of Lake Okeechobee. Some of you may know that because of Hurricane Katrina, the impacts that it had in New Orleans, the Army Corps of Engineers was forced to reevaluate their dam safety standards. They operate and manage a number of structures across the country. In that process of reevaluating their dam safety standards, they concluded that the Herbert Hoover Dike was one of the most vulnerable structures, meaning that there was a risk of failure if lake levels got too high. So as a result of this, they created the Lake Okeechobee Regulation Schedule of 2008. What that lake schedule did more than anything was it lowered the ceiling of lake levels in Lake Okeechobee, which meant to keep lake levels low, there were more releases to the Caloosahatchee and St. Lucie during the wet season months. And we've seen this, and we've seen the impacts of that as well with the numerous discharges and blue-green algae events we've seen on the East and West Coast. I think of 2013, of course, 2016, 2018. Again and again, we've seen this because of the need to keep the Herbert Hoover Dike from failing. Over that same period of time, the federal government has invested nearly $2 billion in the reinforcement of that structure around the lake. As we approach the finish line for that work, the Corps of Engineers has been working on a parallel path to create this new rule book. In this case, they're able to take advantage of a reinforced Herbert Hoover Dike, which allows them a little more flexibility in how to manage the lake. And where we are on this day, and there was a meeting with Army Corps of Engineers yesterday, a public meeting to discuss where we are in this LOSOM planning process, is a new lake schedule that will allow for about a 37% reduction in harmful discharges to both coasts. Those high volume releases that we typically see in the wet season that fuel those algae blooms, we can expect to see about a 37% reduction for the St. Lucie, for the Caloosahatchee. That's a big deal. This lake schedule will also increase the flow of water to the south, to the Everglades. And again, the way that it does this is it allows the lake to get a little bit higher during the wet season, and it allows the lake to go a little bit lower closer to what's called the water shortage line. It really takes advantage of that full capacity that the lake has now with that reinforced dike. So essentially what we're getting out of this is a substantial benefit to both coasts, reducing that polluted discharge, but also sending more of that water south. What this does really is it aligns the operation of Lake Okeechobee, that 700 square mile heart of the South Florida and Everglades ecosystem. It aligns the operations of that with the goals and objectives of Everglades restoration, the multi-billion-dollar state and federal program that will further cut those discharges to the east and west and send more of that water to the south. This process will be completed soon. In fact, that plan will be finalized in December of this year, and we'll see it take effect beginning 2023. So we're really on the cusp of seeing substantial improvements with this new operational plan on Lake Okeechobee.
Great. Thank you, Steve, for that answer. And that is exciting that we will see hopefully those improvements in the coming years. So thank you for that. And again, thank you for connecting us back to the entire watershed. Although we are here in Naples today, the watershed starts all the way up in Kissimmee into Lake Okeechobee and down here into the Everglades. So thank you again for connecting that whole watershed to us here in Naples today. This next question is for Mike. As an appointed member of the Blue-Green Algae Task Force, what are some innovative ways that this group is reducing the impacts of these harmful algal blooms?
So the Blue-Green Algae Task Force, basically we make recommendations. So we don't do much beyond that, but we are persistent. And with Mark Rains, the Chief Science Officer for the state of Florida, we're circling back around and kind of revisiting recommendations we made 2-3 years ago and looking at the status of these recommendations. Has the state implemented these recommendations? So I think the two biggest ones would be focusing, I guess themes would be nutrient reduction. And so that's be over and beyond, that's what we feel is our primary task. What advice can we provide to basically reduce nutrient inputs into Lake Okeechobee, other receiving water bodies, and then eventually downstream? The second focus is looking at how can we mitigate these blue-green algal blooms, these cyanobacterial blooms. And we don't feel that a ton of effort or 100% of the effort should go towards that, because you really need to, that's just a symptom of the problem. The problem is the nutrient loading. And so we think more effort should be focused on reducing those nutrient inputs. So just in a nutshell, what some of the recommendations that we've come forward with would be really looking at where the nutrient hotspots are. So if you look at the DEP, Department of Environmental Protection, you look at the South Florida Water Management District, you look at some of the county efforts, when they go out there and collect water samples and measure the nutrients in them, is there an analysis being done that would demonstrate where the real hotspots are that we should be focusing our efforts on? We don't need to be really pointing fingers or anything like that. Instead, we need to identify where these hotspots are and then come up with solutions. It's going to take everybody to do this. And so that's first of all. And so to that end, basically the district and DEP are redistributing resources. They have some more resources. And the idea is, can they be more strategic in terms of how they sample so we can identify these hotspots? So that's a work in progress. Secondly, we've looked at septic to sewer conversions. And so that's an ongoing process. People need to realize that septic tanks were not designed to remove nutrients. They were designed to remove pathogens, to prevent disease. And so they'll still take organic waste that goes into the septic tank and break it down back into inorganic nutrients, but they really won't do anything with those inorganic nutrients. There are advanced septic tanks, septic systems that can remove the nutrients. It's almost like different wastewater treatments. You know, you have your primary, secondary, and tertiary wastewater treatment plants. And so the idea would be, can we basically remove some of these inefficient septic tanks, get them hooked up to sewers, get them to a wastewater treatment plant where we can better treat the waste and remove the nutrients in that way, and also kind of prevent this chronic, diffuse nutrient input from septic tanks. Now, septic tanks aren't a problem everywhere, but there are places where they really need to be focused. And not every septic tank can be hooked up to a sewer. And there's lots and lots and lots of septic tanks, so we won't be able to replace all of them either. So just for brevity's sake, I would say those are the two things, or two of the more important ones, I think, that we've been focusing on. And again, the overall theme, I think, is nutrient reduction.
Great. Thank you for that answer. And I think the key word that stood out to me in your answer there was the word persistence, and persistence in your recommendations. So thank you for your contributions in that way, because we know that sometimes that's what it takes to move the chains a little bit further on this progress. This next question is for Dr. Heil. Similarly, your work and your leadership with the Red Tide Institute, what are some unique ways that you're working to combat and mitigate these harmful blooms, specifically with red tide?
Thank you for that question. Yeah, we are focused at the Institute primarily on mitigation, although we also have a research program. The 2018 bloom was so severe that it focused at the state level a lot of attention on the possibility of mitigation of red tide. That resulted in 2019 in an initiative called the Red Tide Mitigation Technology Development Initiative, which is essentially $3 million a year for 6 years to fund mitigation research. And this is a peer-reviewed program that funds everybody from academia to nonprofits to state government to commercial entities researching mitigation. We work with a lot of these people. But before I highlight some of the results of this and our research, you got to take a step back. Florida, there were some very hard lessons learned about mitigating red tide early. There was a bloom in the 50s, which a state federal consortia got the idea to mitigate with copper sulfate. This being the 1950s, they literally dumped hundreds of tons of copper sulfate off St. Petersburg, Florida in a bloom. There were some hard lessons learned. Number one, whatever you do, don't make the situation worse with your mitigation efforts, which is essentially what happened. The copper sulfate did kill the cells. Cells died, released the toxins, made the bloom a lot more toxic. And then 2 weeks later, the tides brought the bloom back in again. So lesson one, whatever you do, don't make the situation worse. Lesson two, mitigation efforts have to deal with cells and the toxins. Mike can tell you it's fairly easy to kill red tide. We do it with bleach in the lab. It's a lot harder to get rid of the toxins. And the third thing this highlighted was the need to bring the science to the study of mitigation. You can't willy-nilly throw something in Sarasota Bay to see whether it will kill red tide. We need a scientific process, and that's what we've developed in a 3-tiered system. Tier one, we testing compounds in beakers in the labs, tested on cells and toxins. Probably a good 85 to 90% of the things we test don't work. They get the off-ramp. If they work, though, we move it up to tier two mesocosm studies. Look at the effects on a larger scale. Does it change nutrient cycling? If we put brine shrimp and oysters, what happens to them? What are the secondary effects of any compound? And tier three, is testing in the field. And that requires a very complex series of permits from a variety of agencies. We're working to streamline that process, but it is still difficult to get to that stage. That being said, there's a lot of promising research that's going on about mitigation. We're working with natural compounds produced by macroalgae that are native, that do a fairly good job on the cells as well as the toxins. At this stage, ulva sea lettuce is actually quite good in certain species of Gracilaria red algae. There's some difficulties in application engineering that we're working through. There are a variety of commercial products being tested, everything from slow release oxidizers in the system to nanoparticles. This is a work with University of South Carolina, modifying magnetic particles coated in a polymer they've developed for BP cleanup. Can we adapt them to red tide cleanup? And it's interesting experimentally working with these because you sample them with a magnet, which is a little counterintuitive. And we're working with testing a whole variety of compounds. The two most successful at the moment, believe it or not, the first one is curcumin, turmeric, the same thing that you use in a health supplement or in your cooking. is actually quite effective on cells and toxins. We just did a big mesocosm study last week. Our drawback with curcumin at the moment is it turns everything tang orange. So we're dealing with that. There are colorless curcumin, possibly combining that with other things. We're also testing something called quaternary amines, quats, which are essentially substances we adhere to things, and they're attractive. They disrupt the membranes of cells. They're very attractive because we can adhere them to something, put them in the water, and take them up. We've tested quats on little concrete meatballs. We've tested them on oyster shells. Right now, we've settled on fiberglass mesh that we adhere the quat to, put it in the water, and then take it out again. And I probably should finally mention mitigating red tide is not just dealing with the cells, it's also dealing with the effects of cells. And Mike and I are completing a project on how to mitigate dead fish. One of the side effects of a red tide is a lot of dead fish. I mentioned Pinellas County removed 1,800 tons of dead fish from their beaches daily in June and July of this year. And the question we asked is, how much nutrients? Can we better quantify the nutrients? If we remove the dead fish, how much nutrients are we removing? And also, can we use the fish for something? And Mike's group, he can speak to this a little better than I can, but teamed with a compost accelerator company and essentially composted red tide killed fish. Can we produce a non-toxic fertilizer? And the answer is yes, we can within 3 weeks. So there's a whole range of research going on right now in terms of mitigation of red tide. A lot of basic testing and a lot of compounds and technologies that are actually being transitioned to in situ, in water testing at the moment. So the research is very broad, very active, and very promising at this point.
Great. Thank you, Dr. Heil. And of course, thank you for sharing not only some of those mitigation efforts that are going on, but some of the science that's going on behind the scenes that is not seen by the general public, who may be frustrated by these algae blooms that we are seeing on our coastlines, but not understand some of the science going on behind it or the science behind our water. So thank you for shedding some insight on that. So hopefully it provides a better understanding in the progress that's making towards those mitigation efforts. We're going to have one last final question before we move to the public Q&A, and this question is for Steve. What is the importance of restored flows and improved water quality along our coasts with respect to climate change and sea level rise, and potentially speak to carbon sequestration?
Well, that's a big one. And it sort of ties in with this regional perspective of Everglades restoration. Right now, we're doing more harm than good with our estuaries. We're impacting our seagrasses, our oysters. We realize the very near-term effect of that on habitat. Think of seagrasses and manatees. But those seagrasses are also important sequesters of carbon. The massive river of grass, Everglades wetland ecosystem, including the sawgrass marshes, the cypress forests, all the way down to the mangrove forests and the seagrasses around our coast. Those are all naturally sequestering systems across the Everglades. The key to maintaining that carbon sequestration process is keeping it wet. We know very clearly the solution is simple. The wetter these wetlands are, the more they accumulate carbon. And it's pretty simple. These are plants that are growing year round. We live in a nice, mild climate with a year-round growing season. These plants are very productive. They're producing carbon, they're shedding plant parts, they're producing roots below ground. And the longer those soils are wet, the more that carbon accumulates over time, to the point where these soils can actually grow vertically over time. You might have heard that mangroves are land builders. That is indeed true. And around the coast of the Everglades, we have one of the largest mangrove forests on this continent. There's actually a team of my colleagues from NASA right now with another group from Yale that's looking at the blue carbon benefits of this ecosystem. So they're doing overflights of the Everglades and the mangrove forest to understand at that landscape level their ability to take in carbon. We know that the restoration benefits by sending more of that water south. We improve conditions to our estuaries, which we know are more amenable to the seagrasses and the oysters, but sending that water south keeps this ecosystem hydrated longer, which again promotes that carbon sequestration pathway all the way down to Florida Bay and the Florida Keys.
Great. Thank you for that answer, Dr. Davis. And again, thank you to all of our panelists today for providing insight on the science behind our water. We are going to our public Q&A, and we only have a short period of time for that. So I'm going to take one question from our live audience and one question from our virtual audience. So we will bring a microphone around to you.
Yes, thank you all for speaking today. I have a question regarding the nutrient load that you were speaking about. If and without being too specific, but if you're just to assign percentages or do a pie chart from where those nutrients come, is it from agriculture, golf courses, my front yard, which we fertilize, et cetera? If you were to put those into groups, what would that pie chart look like?
I know.
Well, I think it depends on what your watershed is and what area you're looking at. And I'll ask Steve to correct me when I'm wrong. But if you look at the Lake Okeechobee watershed, it's primarily agriculture. And so most of the nitrogen, I think it's somewhere on the order of 75% of the nitrogen entering Lake Okeechobee right now is from the northern part of the basin and the agricultural fields. If you're in, some of the areas, let's say around Crystal River or somewhere in the Spring District, it might be septic tanks. That might be your biggest issue there. Here in Naples, I would probably think it's a combination of golf course fertilizer, HOA fertilizer, and septic tanks would be the primary sources here. But I'll ask Steve to jump in more because I think his brain's more on these.
Well, that makes sense to me, and certainly north of the lake, consistent with our work. I'll just add a couple of other points to that. And one is this notion of legacy pollution. And it's important to recognize that we have polluted both our lands and our waterways to the point where they have within them a legacy supply of nutrients that even if we could control the pollution that we add to our landscapes and that runs off our landscapes, some of our waterways, and Lake Okeechobee is a good example, with tens of thousands of metric tons of phosphorus sitting on the bottom of that shallow lake. The watershed to the north of Lake Okeechobee, our science team has demonstrated very clearly that we have about a half a century of pollutant within the soils themselves. So all this to say, we're going to be dealing with water quality issues for some time to come. Warming air temperatures, water temperatures will only exacerbate that problem as that speeds up the biological processes that recycle those nutrients. And this really gets to the point where as we take actions to convert septic to sewer, to minimize our footprint on the landscape, reduce fertilizers, to institute best management practices, we also have to consider innovation. And Cynthia described some of the innovation technologies they're looking at for mitigating red tide. We also need to continually advance our understanding of innovative solutions to water quality problems, removing these pollutants in situ, resolving some of these issues with legacy pollutants across the landscape. We know that stormwater treatment areas work. These large treatment wetlands that are designed and managed to remove phosphorus pollution as it makes its way down the Kissimmee watershed or even south of Lake Okeechobee before that water goes in the Everglades. The challenge there is this is a very land intensive technology, requires tens of thousands of acres to make that an impact at the landscape level. But again, we need to continually work on innovation if we're going to solve this water quality problem, in addition to all these other actions that must take place to minimize our footprint.
Great. Thank you so much for the input on both of those on that question. We are going to move to our final question of the day, which is going to come from our virtual platform, and it is from David. He says, I'm in the marine construction industry, and I'm in or on the water every day from Estero Bay down to the 10,000 Islands. What are some things I can do to be more of service in helping tackle this problem? Can I provide samples from different locations, or what else can I do?
Cindy, you want to?
I can speak a little bit to the Red Tide aspect as a former state worker. There are 2 agencies in Florida that are responsible for monitoring red tide. Estuarine and coastal waters, it's the Florida Fish and Wildlife Conservation Commission. They actually have a volunteer program that assists with monitoring, and that helps them provide spatial coverage over a much larger area for their biweekly bulletins. And if you contact them, I can probably provide contact information. In the volunteer program, they have ship captains, everything from retired people to boats to ship captains to people that live on the beaches. And they provide hard to access samples from offshore and at depth. And I know they're always looking for additions to the program, provide them with samples. It's fairly easy to do. You get a bottle with preservative and you take a sample, note the date, time, Latin long, and that can contribute to the monitoring efforts is one aspect. And the other is to be observant. You know the system. And I know the managers and the scientists rely on people that are out there all the time to observe what's going on. Is what you're seeing normal? Is what you're seeing something abnormal? Are you seeing marine mortalities? Is the water discolored? When I was a state worker, a lot of the impacts that we investigated, we did rely on the public to report, whether it's dead fish or signs of offshore anoxia associated with red tide. State workers do a very good job monitoring blooms, but they can't be everywhere all the time. So the public definitely serves a purpose in extending that monitoring network and kind of being eyes on the water, I think. And Mike can probably address the DEP, which has taken over a lot of the cyanobacterial monitoring in the state. I'm a lot less familiar with that. Mike, can you speak to that or no?
I think the same thing would apply there. You know, when between fishing guides and you know, marine construction people and things like that, by being on the water all the time, you really have your finger on the pulse of the system. And I learned so much talking to these people because they're on the water. They know what's going on. And so I would just echo what Cindy said, you know, document, make observations, report, you know, fish kills, report discolored water. And that would really be helpful and would really, you know, extend, I guess, our monitoring network. In terms of the freshwater systems, the same things would apply there. And, you know, if you see discolored water, if the water's looking pea soup green, if you see kids or dogs near water where it's pea soup green, maybe say, you know, that might not be a good idea. Maybe you should look at the blue-green algae dashboard by the DEP and learn a little bit more about these issues. I know one problem we deal with with the task force and the Department of Health is dealing with this more so, is there's a general complaint that advisories aren't put out fast enough or in enough places. And, you know, there's just not enough people to react fast enough and everywhere when these blooms are happening. So there has to be an education where we just need to tell the public, you know, something like if the water's green, it's mean, you know, and so you stay away from it, or just things like that. Or maybe we just put out general signs like our alligator signs, you know, and just say alligators are known to frequent this area. Well, blue-green algal blooms are known to frequent this area. So we really do depend on the public as an extension of eyes and ears for our monitoring efforts, and that will also help our response efforts.
Great. Thank you so much both for your answers. And this is going to conclude our portion of the public Q&A, but I do want to give our panelists a chance to share any closing remarks.
Well, I'll let Steve go last since this is kind of his show. Cindy, do you want to go first? Do you want me to go first?
Yeah, I just very, very briefly tell people at the moment there is no red tide offshore. Talking to Professor Weisberg at the University of South Florida, the physical conditions are not right for a red tide this year yet. So at the moment, we're safe. And if we have a normal year, then I wouldn't start looking for one until the end of summer. So we're getting a bit of a reprieve this year, which is a good thing.
I think I would just like to add that, politics is a big part of this. There's a lot of different stakeholders, some powerful stakeholders, some not so powerful stakeholders. But, as the voting public, you really hold the cards here. You need to let your elected officials know how important water quality is, how important Everglades restoration is, and just really keep pressure on the officials. They need to know that these are significant topics. These are significant concerns for the constituents. And so I would just recommend that.
I'll just add to that. That was a great point. And our economy today depends on our environment. It depends on clean water, our real estate values, our tourism, boating and fishing. That is all dependent upon healthy, clean waterways, healthy Everglades. And really, to that point, with Everglades restoration, it's about infrastructure and it's about the dollars needed to build the projects, the key projects. The C-43 reservoir along the Caloosahatchee is moving along. That's great to see. C-44 along the St. Lucie just completed. That project is filling up. We need that reservoir south of Lake Okeechobee. The Everglades Agricultural Area Reservoir is really the key project to redirecting the flow of water back to the south. That will take the biggest bite out of those unwanted discharges to the east and west and redirect that water to the south. So it's about infrastructure, and it's about really with the state funding, the robust state funding we've seen over the last few years, it's now about the federal dollars needed to build that reservoir.
Great. Thank you again to our wonderful panelists that we had today. We hope that you understand a little bit more about the science behind the water and enjoyed this way to spend your World Water Day. Again, thank you to Glenmede as well as Arthrex for hosting us today. And I hope everybody has a great rest of their World Water Day. Thank you for joining us today.